Okay, so here's the Excel document that we were going to use. Check this out. Here's a sample, and then here's a previous semester's work that we're going to fill in and make this our own. Okay, look at what I got here. The number of filters, we went 1 through like 16. You can go up to 20, whatever we want. Okay, here's the mass of one filter. So mg is this multiplied by 9.8. So we changed it to grams to kilograms, multiplied by 9.8. And then we had a constant height. We'll just find someone tall in the room that drops it from a certain height, and then we'll go from their feet to the bottom of the landing so that we'll have a known distance. And then we'll just use the same distance every time. And then you guys, with your amazing stopwatch ability, will time how long it takes the coffee filter to reach the bottom where the feet are of the person to the actual floor. And we'll take those times so we can get an average time. And look what we did here. Terminal velocity is just simply distance over time. And then what's t squared? I just take it and I square it. So there's the chart. And out of that chart comes some really interesting thing. Oh, I was wrong about, if we graph mg versus terminal velocity, okay? If we graph mg versus terminal velocity instead of the right way, we should be graphing terminal velocity divided by mg. All right? I'll have to decide whether we want to do it that way. This is the wrong way, but it'll give you really great results. This is the right way of doing it, but it'll give you 1 over beta, right? Something like that. So it depends on what you want. All right? This is the wrong way to graph it because really terminal velocity depends on the weight, not the other way around. So a more correct way of doing it is terminal velocity on the y-axis and the weight of the coffee filters on the x-axis. But can you see that the curve happens, which means these aren't directly proportional. If you double the weight, you don't double the speed. Terminal velocity is not doubled when you double the coffee filter weight. What a bummer, because then the integral would have been as easy as the one I just did for you. All right? But this is more in real life. Things have a tendency to be v squared instead of v, which kind of ruins everything, but what are you going to do? Okay? So when you look at this thing over here, look at the numbers that we got working here, and we got gravity is 9.81, of course. The mass of the coffee filters, we'll redo it, make sure our coffee filters are the same. The distance that we fall, that'll change depending how tall somebody is, right? And then the area of the coffee filters, we did the kind of like the effective area of the coffee filter, and then we need the density of the air that it's going through. So we got everything we need, and all this stuff is going to go together to become like a beta, like a constant. And then if you read real closely here, you end up C, find C. What's C? C is that coefficient, drag coefficient. That thing that looks like a P on the board, that's not P, that's rho, the density of the fluid. Okay? So all that stuff is incorporated into what we could call beta or alpha or something like that. Okay? So how to get a 20 out of 20? You're going to graph mg versus terminal. That's the wrong way of doing it, but it gives you beta. All right? It won't give you beta because this will be a curved line. But when you graph mg versus terminal squared, the slope of that line will be beta. Okay? If you want to graph it the correct way, it would be v squared versus mg, and then it'd be 1 over beta as your slope. Either one is fine with me. I'm just kind of cutting you some slack. So you want to find this constant beta, and then find c, knowing that beta is 1/2 the c times rho times area. Get it? And then you do a lot of calculus, and you figure out what the equation of equation is, and then find the right integral from your calc or from the web, and then use this beta and lots of calculus to determine the velocity at a 5/100th of a second, at 1/10 of a second when we're using 8 filters. And then try to determine the distance fallen when the velocity is 95% of terminal. That's going to be a really bad integral to get that. That's why it's called the bonus. Okay, include in your write-up, along with the 2 graphs, all the work you did to calculate the v as a function of t using calculus, a brief theory, all the stuff I requested above, plus a discussion with those 3 parts. All right? So that's the bold plan. And that's what we're going to do. Let's take a break and do it right after that.